Well, so I quickly saw the advantage of using this software, especially if I was going to have to keep starting over, simply because you can draw in all three dimensions at once. And when you're drawing on paper, you've got to draw three different views to actually render it in three dimensions, so that you can make sure everything is not conflicting with itself and other trades. So now I use SketchUp for any job that I need to plan three dimensions in, especially when space is at a premium. Look around here. We'll move over. And get into where I've already copied the house and cut into it. So, like I said, he drew the house, and then I butchered it up and put the systems in here. The project design finally ended up like this. Here we have two ducted mini-split inverter driven heat pumps. These are the air handlers, and these white boxes here my cursor's on, those are the air handlers. The mechanical room acts as a return plenum. Back here you see the ERV. This is fresh air coming in. It dumps into this room. There's a above this door, there's a transom here that allows air in above the door from the rest of the house. And so you see the associated supply ducting come off of each mini split. Yellow for this one's all the supplies for it, and then blue for this one. You see this blue system here, it feeds this main large area of the house, which serves as the kitchen over here, and dining room in the middle, living room where the little guy's standing. This is you call this a bedroom, but this is actually a library. This is an office. This is a bedroom, but this one is fed off of the other system. It's yellow. This is the laundry. This is a stale air duct to the ERV with a zone damper. So they have a closet here they hang their clothes in. That's talked about in the other video, the 1 watt house video. We'll swing around here and look at the ERV more closely. Here we have the fresh air intake. This section here is where a preheat element is, and anytime that temperature is 18 degrees or lower from the air coming in, it kicks on that heater and preheats it so that we don't freeze up the enthalpy core. It's a rotating disc that transfers the heat and moisture energy. This is a duct for the common area around next to the kitchen, so they can kick that on when they want, and it opens this black section down there as a damper that boosts that output. As I mentioned in the other video, it pulls from both bathrooms all the time, so no damper to this bathroom. This is a bathroom. This is a bathroom over here, and these have boost buttons as well that are on timers so that you can increase the output to the bathroom if needed. So that is that. So you see the intake and the exhaust. So, but I'm getting a little ahead of myself because all the design started with the load calculation. You know you can't design ductwork until you have that. And the energy usage engineer provided his own load calculations that he promoted as being better than Manual J, a method we use here in the U.S. because his method was German and so was he. But actually he's a very talented guy and he does what he does very well. My load calculations were very, very close to his, however. My loads were just a bit higher, which is what he expected. But so let's have a look at this load calculation. What we're seeing here is the drawing, what's called the drawing board to this load calculation program. This load calculation is EliteSoft RHVAC. And this drawing board is the most convenient way to enter the information into the house. And it also allows you to use the Manual D add-on. The default method that comes with the basic program is just text entries, you know, window wall heights and lengths and what direction they're facing. You can see up here at the compass point. So this software is about $500 for the main HVAC program, and so is the drawing board program. I also have the Manual D add-on program, and you can see the Manual D overlay. Zoom in here. You know, it's depicted by the blue ducts are the trunks, and the hatch marked items are the runs. And we'll open up the load preview window here, and what you see, you can see individual rooms line by line and their attributes listed in the column headers at the top. Notice also that each room has a sensible gain, a latent gain, and a net gain. That's both put together. A sensible loss, and a CFM value for heating and a CFM value for cooling. You know, and then you have the actual, which is typically, or the design CFM, which is going to be the higher of the two. You might be surprised to find out how much just rotating a building will change its load. Because, you know, especially when one of the sides of the house is more glass than the other sides, you're going to see a big difference. And, you know, you might have a house that one way it sits, it takes 2 tons. You turn it, and it takes 3. So the rule of thumb is not valid. Well, here we see the building rotation hourly net gain. Along the bottom we have the time. Along the side we have the building gain in BTU an hour. Each color represents a different direction the front door faces, which is how the software references how the house is oriented. This bottom red line is actually the way the house is oriented, because this was engineered by a professional energy designer, so the actual house was thought about before it was ever built. And it reflects on my software as well. I get this, you know, similar results as to what he had intended. And so you see up here we have what colors? That's the front door is facing southeast on the really worst scenario, and its front door is facing north on the best scenario, which is the way that it is occurring. And you'll see this is actually, I've not even selected all the options for the software to show in this report, and this is page 46. There's building rotation tonnage. It's showing the same thing. There's north, northeast, east, south, and then on. And you'll see how it changes. And so here's north, there's south. Those seem to be the 2 best ways to orient that house. These are also building rotation reports and how it changes the CFM room by room. Load summary. This is the room cooling. This is the cooling load load bar graph. So you have the library, the kitchen, the living room, the dining, atriums, which is the clerestory that's above the main area, the master bedroom, the hall, master bath, bedroom 2, laundry, the bath there. And these are the heating loads. Detailed rows. There's a lot of stuff. This tons of stuff. Okay, here's something interesting. Bar graphs. This is, or pie charts. This appears to be for well, anyways, it's either for heating or cooling. One's the other. I'd have to look at it longer. I don't want to take up the time. Building pie chart. Okay, this is loss. This is heating, and there's cooling. and it even includes AED excursion, which is unbalanced class loads. There's pressure losses that you see from the Manual D report. I'll stop there for a second. You get a glance at those. You notice the available static pressure on these ducted mini splits is next to nothing. You really got to be careful when you're sizing ductwork for that, and just really err on the side of bigger, because they just have no fan power. They're really intended to be just piped right through the wall without any real trunk or runs on them. More Manual D stuff. This is a psychrometric chart. Generates these, and for both units. This is the exposure diversity. This is the AED I was talking about. We were talking about glass loading for both systems. What you saw before, that's a load preview report.